Okay. So Solidcam is an integrated CAM software inside of SolidWorks. And so there's a lot of other integrated CAD softwares, or sorry, integrated CAM softwares, and there's plenty of other CAM softwares. So really the question I'm trying to answer today is why Solidcam and why this is the superior CAM software. So today I believe that there's four areas where I think SolidCam has the advantage over other CAM systems. First being the setup and the integration that SolidCam has. Next, we're going to talk about the operation creation and all the different types of operations you can create inside of SolidCam. Then we're going to talk about the iMachining technology, what it is, how you can use it, and all the benefits that come with it. And of course, some of the automation that SolidCam can do as well. And then we're going to talk about the post processing and all the different simulations inside of SolidCam. So we'll start with the setup and integration. So right when you finish designing your part, we want to make sure that you're ready to go inside your cam and start programming quickly. So in SolidCam, it's very easy to validate and associate the part setup. As you can see over on the right-hand side, I actually brought in my vise or my fixture and I mated it as an assembly inside of SolidWorks. It's very easy to define your coordinate system, stock, and target part, which are the only three fields that we have to fill in during our setup. And then this creates the initial associativity to the workpiece. So if we change our fixture or if we modify our part, our setup will automatically update for us. When I go ahead and open up SolidCam, you'll see where I'll go over all the different benefits from being associative. I'll show you how it eliminates the need to redo setup work. And then any design changes, like I said, will update your CAM part. So I'm going to go ahead and open up SolidCam. And the first thing you'll notice is that we are running completely inside of SolidWorks, right? And I do want to make this clear that SolidCam is not the same as SolidWorks Cam, which is a default add-in in SolidWorks. So over on the right-hand side, you can see that we are just working in an assembly. I have my vise and I have my part. I even have a model just for my stock. And so SolidCam, like I said, is running as an add-in. So all I have to do is switch over to my SolidCam manager to control my cam part. So the first thing we're going to do is I'm going to open up my cam part, and this will allow me to take a look at my setup. So first, I want to define my CNC machine. In this case, I just grabbed a 3-axis VF4, Haas VF4, but I do have a library of all different types of machines that I can use. The first thing we'll define is a coordinate system. Mine's already defined, but I'll show you how easy it is to add a new one. All you'll have to do to get a coordinate system on your part is select a face. It's going to automatically pick up one of the default locations. In this case, it's top corner of model box, so it's in the same location as our existing coordinate system. But I do have a list of different default locations. If I don't like these locations, I can scroll down and I can modify the origin, the rotation, and I can manually modify this position. But it just takes that one click to grab a face to put your coordinate system on. Next, I can control my tool levels, but this is the menu that we can automate. I normally leave these at default, and if you do too, we can automate this page so it'll just fast track past this page. And that'll bring me back to my coordinate system manager. If I do have multiple setups, it's very easy to grab all these different coordinate systems so I can program on multiple setups or multiple sides. Next, we're going to define our stock. Like I said before, I created a boss extrude to represent my stock, and I was able to just grab that. I do have a lot or a few other options I can define my stock. If I'd like to define a box, I can just grab my part and I can set offsets off each of my surfaces to define my stock. I can also just define my stock size manually with absolute coordinates or manually filling in my stock size. But for now, we'll exit out of here and we'll stay using that solid one or that stock I already defined. Last thing that I have to define is my target. So like I said before, we are working inside an assembly. So Solidcam is just making sure that we are looking at the same part and want to machine this specific part, solid one. So all we had to do was grab that. We can hit OK. And normally we would be all set and good to go. But since we are using iMachining on this part, we do have to fill out our iMachining data. And once again, I'll show you more in depth what iMachining is. But here I'm going to select a preset database that'll have some feeds and speeds for me to use. I can set my material. I can also just turn this on and use the same SolidWorks material I have assigned to this part. And then next is my machining level, which is just how aggressive or conservative I would like to cut. Now, those are the options that we have to define as we set up. And now we are good to go to add some operations on our part. So just to recap, it's a very logical and associative setup. There were only 3 areas that we had to fill in. It's running as one window. It's just one tab running inside of SolidWorks. And then, like I said before, any design changes will automatically update your setup. Next, we're going to go ahead and start talking about the operation creation inside of Solidcam. So I'll show you that it's very easy to set up these operations, and they all have a very similar workflow as well. I'll show you the toolkit, how you can create new tools on the fly or import existing tools that you already have. And then I'll also show you how you can tweak all aspects of your toolpath. So another great thing about Solidcam is that it's very versatile. So we have 2.5D milling toolpaths, 5-axis simultaneous. We have mill turn and Swiss machining toolpaths. There's also wire EDM. So Solidcam has all these different types of operations, so it can fit all different types of machines. Now I'll go ahead and go back into my Solidcam part. And I'm just going to open up my first operation here. Right? So the first thing we're going to do is just notice that this is a pocket operation. We can see here the technology is set on pocket. What we'll have to do first is define what we actually want to cut. What I did here was I was able to just grab the bottom face of my pocket, and that'll pick it up for me. Now, if I move over, this is just more options that we do have, but we're not really changing any of these. I already defined my stock, so I can leave this stock tab as is. But if I do want to modify my stock, I can do it in here. Same thing with the target fixture. Here, if I hit show, it's a little hard to see, but I did grab my vise. And then next, if I have any floor fillets in my pocket, I can apply those in here, but I don't in this case. We're going to go down to our tool, and I'm going to go ahead and select one, which will open up our toolkit. So in this part, we've only have 2 tools defined, just an end mill and a face mill. But over on the left-hand side, we have a small library of different tools that we can bring in and create for this operation. Now, Solidcam will automatically figure out which tools we can and can't use in this operation. So you'll notice that we don't have any drill tools here, for example. So if I double click an end mill, I can bring in an end mill, and it's just at a default size. It's at 6 millimeters, but I can very easily change that. And it'll also give me a quick preview of what I'm actually dimensioning inside my tool. So here, the cutting length, it's going to show me visually where that is. All right. Over on the right-hand side, I can set my preset feeds and speeds, and I can build this library out for all different types of materials. So here I have an aluminum preset feed and speed at 1,000 at the X and Y feed. I can really easily add a new material, change the name for a different type of material, and apply these feeds and speeds. So the next time I use this tool, I can quickly select these feeds and speeds, right? I also do have access to my holders, any shanks that I have. If I move on down, these are just some options how I can import existing tools. Oops. Let's exit out of there. But I do have a few different options from existing tool libraries. I also do have some machine setup. And then I also do have my fixtures in here as well. So here's just a few different types of fixtures that I have, and I can double click them and bring them in. But since I already defined my fixture, I don't need to do that at this time. So for now, we'll exit out of here. Let's go back to our tool or our tool path, and we can see that our end mill is defined. So we can go ahead, move over to our data. Now, if I want to manually edit this data or my feed and speed, I can do that in here. I can also control my coolant and then any tool change positions as well. I'm going to move down to my levels. And the first thing you might notice is this green box here. So that's our pocket depth. Since we grabbed the face on our pocket, this feature became associative. And this green box is letting us know that any design changes to this pocket, this field will update for us. All right. I'm going to move on down to my technology. And this is where I can define the pattern or the direction that I want to cut in. So here I have a contour. And on the bottom left of this window, I can see a preview of what that toolpath will look like. I can also define any offsets very easily. I can turn on my finishing passes if I'd like them. However, I do have some options to control my contour toolpath, how I would like to address corners. Here, if I had an open pocket, I can turn this on very easily. Then I have some advanced options for sorting, draft angle. We'll move on down to our link, which is just our ramping. Pretty straightforward. We can define how we'd like to ramp into this pocket. We can also define our lead in and lead out very easily. But that's all we really have to define in this toolpath. Next, I'm going to save and calculate. That'll calculate the toolpath for me, and we can even see a preview of it on our part. Something you might notice is that we do have a lot of different save icons down at the bottom of our toolpath operation. So Solidcam makes sure that we are very frequently saving, which will create temporary files so that if we ever crash or we lose power or unexpectedly close the file, we can easily pick it back up at the exact point where we left it. So Solidcam is just very frequently saving for us, and it's prompting us to save constantly. Now, I do have a few different simulations inside of SolidCam. I'm just going to show you one before I go too in depth. I'm getting a slight graphics error, but that's a computer issue, not a software issue. But I'll go ahead and I've got my simulation. And this is just one of the basic ones. I'll show you some more later on in this presentation. All right. Exit out of there. Save our toolpath one more time and close it out. So let's go back over to our presentation. And now just to recap, there is a large, easy to use library of operations. I didn't go over this too much, but over on the right-hand side, we can see the large list of different types of operations that we have. And you can even see that these operations, some of them are very specific to features. Like we have a pocket, we have a slot, we have a T-slot operation. SolidCam also scales to the client needs. Now, even though that SolidCam has all of these toolpaths, SolidCam is module, so you only pay for what you need. If you only have a 2.5D machine and you have no use for 5-axis toolpaths or mill turn toolpaths, you're not going to need those. You're not going to pay for those. You're just paying for the bundle that you need. All right. And then a little bit later on, I am going to show you the effortless recreation of operations. And there's a few ways how we can do that. All right. Whoops. So next, we're going to talk about iMachining and automation. So iMachining is a very smart toolpath that basically only looks at 3 parameters, which is the material that you're cutting, the tool that you're cutting with, and the maximum machine capabilities. Now, iMachining will create a morphing trochoidal spiral that will conform to the features on your part. So I will show you an example of that. But the way that iMachining is cutting, it will save you up to 70% or more time on your cycle. You'll save 5 times longer tool life. You end up cutting with the full length of the tool or the maximum length of the tool that you can. And iMachining is also designed for first part success. So even though that this tool path will run very fast, it's not going to crash and it will give you a good part. Over on the right, this is just the iMachining wizard. But once I go back into SolidCam, I'll give you a little bit more of a deep dive on what that looks like and what it does. Right. Now, over on the right-hand side, I took a standard pocket toolpath, the same one that we already saw or created. And I was able to use iMachining to get that cycle time down to 2 minutes and 7 seconds. So almost half the time we're able to create that same exact pocket. Now, iMachining is also very great at rest machining. So it will pick up where the stock is, how much stock is left. So it'll ensure that we're not just cutting air. And like I said, iMachining will instantly optimize all your toolpaths. Here's just a little video of what iMachining looks like actually in action. And what's really cool about it too is once this part is done, we're actually able to take this tool out and touch it because it's not hot. iMachining will push all the heat from the tool into the chips, so not into the part or into the tool. The heat will go into the chips that are flying away. So that'll make sure that that tool doesn't overheat. All right. So what we're going to do now is open back up my SolidCam, and I'm going to suppress this first toolpath that I showed you. And I'm going to unsuppress my iMachining. Just double click to open that up. And you'll notice that this is a very, very similar workflow to that pocket toolpath we already saw. The only difference is this technology wizard, which is where iMachining is. So just like our first operation, we had to just grab our face here, the face of our pocket, went ahead and we're using the same exact 6 millimeter end mill. And on the left-hand corner of this window, we actually get a preview of what this tool will look like. We're going to go on down to our levels, which once again, we don't need to do anything in here. It's already associative since we grabbed that pocket face already. And next, we're going to go to our technology wizard. So right now, I have this turned all the way up to an 8. So 8 is the most aggressive that iMachining will go. Now, I say aggressive, and I say that iMachining will run very fast, but really, iMachining is only looking to maximize your machine at about 17% of its capabilities. So it is designed very safe. Now, if I come over to the modify cutting conditions, I can modify some of these parameters to speed up our toolpath just a little bit more. So if I maximize my cutting angle a little bit, just up to 80 degrees, and my minimum chip thickness, I'll bring that down a little bit. That'll allow me a little bit more speed while cutting. So let's go on down to my technology. And here you're going to see that my step down and my cutting angles are locked off. So that's because the iMachining is turned on. If I turn this wizard off, that will let me customize these parameters. Now that is possible, but it is definitely recommended to keep this wizard on so you can fully utilize iMachining. Right? Let's go ahead and save and calculate this toolpath. And take a look at what it looks like. So the first thing that I want to point out is how the tool addresses corners. So iMachining recognizes that corners are really where the material starts to build up on the tool and the tool load starts to get really high. So we're only going to take small bites or small cuts into these corners at a time to make sure that we're not overloading these tools, causing them to break or disform, right? But for now, we can save and hit exit. So one last thing, so to talk about automation a little bit more, I want to highlight the drag and drop templates that Solidcam has to offer. So any of the toolpaths that you've already seen or any toolpaths that you haven't seen yet, we are able to create a template from it. And this is a drag and drop template as well. So my iMachining, for example, I'm very easily able to right click and create a template. All I have to do is name it and it's in my library. Now it's very, very easy to use these templates. So I've already pre-filled out all this information on my toolpath. And now all I have to do is left click, drag and drop it onto the feature I'd like to apply this toolpath to. So I'm just going to take my face mill and drag it on top of my part. I can see that that toolpath is calculated automatically for me. This is a spiral toolpath, but I can go in and change that if I'd like. But as I go through, you can see that everything's picked up automatically for me. Right? My tool, it's using the tool for my template, just the face mill. I can access my levels and I can see that they are already associative. My technology, this is where the spiral is set, but I can easily change this to a hatch if I'd like. And I can recalculate and see that updated toolpath. So the drag and drop templates are a really great tool. And not only can you create a template out of one toolpath, you can actually grab a few and create a template out of those. So if you have a block and you always rough the contour out first and then finish, you can grab those two toolpaths, group them together to make a template, And now the next time you want to rough and finish a block, all you have to do is drag and drop, right? Same thing with drilling. So if you spot drill, drill, and then tap, you can bundle those together. So it's very, very easy to reuse these. Okay. So let's go ahead and go back. Like I said, we can take any toolpaths in here and create a drag and drop template. But now just to recap, iMachining is shortening these cycle times with ease. It's giving us more tool life, and it's very, very easy to use. Once I was inside that iMachining toolpath, all I had to define was the pocket and the tool that I was using, and then just how aggressive I would like to cut. I didn't have to fill that in, right? And then once again, iMachining, as long as these other toolpaths are associative to the part. So if you go back and make any modifications to your SolidWorks part, that will update your toolpaths automatically, right? So the last thing we're going to go over is post-processing, and then some of the simulation that Solidcam has to offer. So Solidcam is a big fan of writing custom posts specific for the client machine configurations, right? So like I said, the posts are written individually offsite for your specific configuration. We test a range of different types of geometry to ensure that this post will spit out exactly what you need it to. We also test all these posts with you, and we do have a long cool off period or support period for these posts. We also take sample posts from the client or you, and we'll make sure that our post will be spitting out or generating the same exact G code. The end goal of why we write our post custom is to make sure that you have as little manual G code editing as possible. All right. So here is the full machine simulation inside of SolidCam. I am going to go back in my part and show you what this looks like, but here's just a quick preview. So you can see that we have the machine, we've got our fixture, we've got our tool. Pretty much everything that'll actually be inside your machine will be inside this simulation. All right. So let me go ahead, open my part back up, and I'm going to simulate my whole part. Let's go over to machine simulation. So here I have my VF4 Haas. If I look around, I can see that my fixture is on the table, and I've got my part in there as well. So this is very, very accurate to what you'll see. We'll slow this toolpath down to begin with. And maybe speed it up just a bit. But we're able to actually see this whole part cut, you know? And what else is great is that there is collision detection on every aspect inside this machine, whether it's the tool itself, the stock, the holder, the fixture, or anything else inside the machine. It'll be able to detect that collision for you and notify you. Speed this up just a little bit more. And that's that. Right, so pretty straightforward. I can come over. I can see all my moves here. I've got the full list. Now, just to recap, we are making these posts custom for your needs. Over on the right-hand side, this is called the Machine ID Editor. So we're able to control a few settings about our posts here, but it's recommended not to play around with these too much, as you might stray too far away from your original post. But we do have a lot of options in here. And like I said, This will minimize manual G-code editing. And then we do have the full simulation that will reduce the machine crashes because frankly, it is a lot cheaper to crash on the computer than to crash on your machine. Now, to recap what we went over today, we went over the setup and integration inside of SolidCam. We went over the operation creation, all the different types of operations inside. iMachining, how innovative it is and how it can save you a lot of cycle time and tool life. And then the post processing and the simulations that are inside of SolidCam. Right. So if you guys have any information or if you guys are looking for any more information, please go to trimech.com/solidcam. And at this time, I'll be taking any questions that anybody has about SolidCam.